Hello and welcome to another edition of For the Record. I'm Sean Murphy. My guest today, Fran Jackson, astronomer and visiting lecturer of physics and earth science at Framingham State University, a returning guest to the show, but it's been a while, so welcome back to the show.
Thank you. I appreciate your asking me.
You know what? One of my favorite subjects, because I'm a fan of all things space and astronomy. Not so much physics, because that's far too complicated for my brain to comprehend, or the math that goes with it. But what's going on in the world of astronomy these days? What's new and exciting?
Oh my gosh, how much time do we have in this show today?
Apparently there's a lot going on.
Yes, there is. And I want to thank you also for saying astronomer, because usually when I tell people I'm an astronomer, they give me their signs.
Oh, yeah.
So, yes.
It's funny, because I just watched a show, because I'm all into all the science shows, where they actually discussed the fact that way back in the day, astrology and astronomy were combined until people realized that one was kind of bunk and then the other part was real science.
Yes, but unfortunately, there have been periods in history when astronomers have had to go back to astrology records because people didn't care about astronomy, about the real science. So you had to kind of fill in the missing information. But today, yes, we know the difference between the two.
Unfortunately, there's probably more people opening up their newspaper to read their signs for astrology, unfortunately, than they would to read a good science story, I would imagine.
Yes, unfortunately. Just about everybody can tell me what their sign is. Of course, then I have to tell them that it's wrong because, what they're reading is a few thousand years old.
So what's going on in the world of astronomy?
Oh, lots of stuff. First of all, just a few months ago, we had a spacecraft called Dawn that was in the region of the asteroid Vesta a few years ago. Finally get to the former planet, former asteroid, now dwarf planet Ceres, where it will stay for about a year.
Is it orbiting it right now?
Yes, it is.
Okay.
It's just started. And we'll be starting to get more and more information from there. But the big stuff is in July.
Can't wait for New Horizons.
Yes, it'll actually get to Pluto, which was actually a planet when the spacecraft left.
When they launched it, now that has been downgraded to a dwarf planet as well.
Yes, it is, even though we're finding more and more moons. Right now, there are 5 satellites going around there. When it set down, we had just found our second and third. So
it's exciting. The images that they're showing now are grainy, but it's still a little ways out. But we just don't know anything about the planet,
Right. All
or
we know is
planet.
that, whatever it is. Yeah. In 1989, we actually saw. Well, in 1978, we found our first satellite going around it, our first moon. And in 1989, when it got its closest approach to the sun, we found it start growing an atmosphere. And that atmosphere is still pretty much there. However, Pluto is moving further from the sun, so there's a chance that we'll lose it.
Well, the important thing is its rendezvous has to be at the right time so that you can see it, so that you can see what's going on, right?
Yes, and that will be in mid-July. And in fact, they've got the times all set out for it.
It's amazing, they used ion power. That's pretty rare at this point to get the ship out there, the spacecraft out there.
Yes, Dawn also had that, which is why it took 3 years to get from Vesta, which is on our side or the near side of the asteroid belt, to Ceres, which is on the outer part. But that's okay because now it's here.
Ion power is good for long distances, but not for speed, right?
Right. It does make things take a lot longer time.
Do you see advances in propulsion as far as space travel, in our lifetime, something significant?
Actually, the last thing that they've started to do is go back to something that they were talking about during the 1980s, and that's a solar sail.
Ah, yes.
Yes, if you remember that, where the idea is to just use the solar wind, that is the mainly electrons, the charged particles that leave the surface of the sun, and have them travel just like a sail here in the waters. Of course, it would be much longer time.
Yeah.
It would be if you have nothing else to do for several years, and you'd need a really, really huge, very thin piece of sail.
But again, these things are too time-consuming. Like, let's talk about Mars for a second. If you're going to send people, obviously the orbits have to be lined up properly for the shortest amount of time. But get there quicker. I need to get there quicker. I'm probably watching too much science fiction, and that's why I'm not expecting warp drive anytime soon.
I hope not.
But we need to, we need to somehow get a breakthrough in propulsion.
Correct. The closest or the shortest time we can get to Mars right now is about 6 months.
Just on current technology, though.
Yes.
Right.
That's about how long the major spacecraft have been there. Then if we want to go and come back, we're talking 2 years, 2 of our years.
Right.
And that includes 6 months up, 6 months back. And then, of course, you'd want to spend significant time.
Yeah, you don't want to just touch down and then leave. What's the point of that?
Absolutely.
And obviously, you hear more and more serious talk about getting people to Mars. Is it going to happen in our lifetime? Next 20 years?
Maybe more your lifetime.
30 years? Oh.
Now, remember, too, that there has actually been talk about people doing one-way trips there.
I know. That's big. I mean, wow. You really have to be dedicated and committed to not have the desire to come back.
Right, which means you'd probably have to be a senior citizen, because they figured that they'd probably want somebody who really didn't care about coming back or not, which is kind of sad.
But it is sad. But you also want them to be young enough to be able to put in some science while they're there too and contribute, right?
Oh, absolutely. But there are a lot of people, that are hitting the golden age that are still really rip-roaring and ready to work. So it's a possibility. However, there has been talk. In fact, I heard a talk by, dare I say him, Neil deGrasse Tyson.
I watch his show all the time.
Yes.
Yeah. He's an astrophysicist by
he
trade.
is.
Yeah.
And the talk he gave, someone asked about going to Mars, and he was saying right now what we would have to do would be, we couldn't terraform Mars. Basically what we would have to do would be to bring our technology up there and pretty much make Earth conditions on the planet. So we wouldn't be changing Mars, we'd just be contributing what we have here and taking it up there.
Well, here's the thing. Mars is a little smaller, and I think that's the reason they said it eventually had lost its atmosphere.
Yes.
And it just couldn't hold it, and hence there's also no plate tectonics, and there's no electromagnetic. It's all connected.
Right. Its atmosphere is about 1% of ours, to the point where if you were standing on Mars, about 90% of it would be below your knees. And most of it is carbon dioxide. So there'd have to be a lot of work being done for that.
Yeah.
Yes.
But the fact that they can conceptualize the fact that you could terraform a planet, it actually isn't that hard to know what you would have to do. It's just that it would be a daunting task, obviously.
Yes. You'd need a while.
Yeah, a long
you really
while,
would.
generations to actually see some kind of transformation in it. And then, even if you do it, because of the planet's size and everything, it wouldn't hold forever, right?
Probably not. From what we found, that happened to its water.
Yeah.
Now, we know there's a lot of water buried underneath the ground. We have, the 2 polar caps are still there. There's a couple percentages of water in the atmosphere, but the atmosphere that Mars has, water can't exist as a liquid there.
And the great things they say always happen by accident. One of the rovers was just kind of going along and dug into the ground a little bit, and you happen to spot not water itself, not even ice, but just hydrogen, whatever it is.
Yes. In fact, what happened was the wheel broke.
And it was dragging, right?
Yes. Yeah. And as it was lifting up the topsoil, and this stuff suddenly was revealed. So
now the $1 million fact that scientists say is follow on Wall Street, follow the money. If you want to try to find life in science, follow the water.
Yes.
Right? Water is pretty much a prerequisite for the most part.
Right. And surprisingly, though, we're finding it in more places than we thought.
Moons all over the place, asteroids, comets,
Yes.
It's fascinating stuff.
In fact, some people still believe that a lot of the water we have here was brought to us by comets.
I want to go back out to Pluto for a second. Why is it that the Hubble telescope can see into distant galaxies but doesn't do a good job of seeing closer up things like the edge of our own solar system?
Oh, because Pluto is so small.
Is that what it is?
Galaxies are so large.
Yeah.
You can really get to them. But, plus we have really nothing to think about to use as a standard. Galaxies, we know, those are stars.
Right.
But Pluto, well, we know it has an atmosphere, so that can somehow be seen. The Hubble telescope can show us variations in what appears to be color, which leads to the fact that there could be variations in its surface features. But we really need to get there to actually see.
And the thing is, once we do get there, Pluto may be it may be common of what's in the Kuiper Belt. It may be just, that's just one of many things that we spot out there, right? As far as like what it is.
Yes, since the 1990s, they've been finding many, many things. In fact, it's almost, if you want, there are probably as many objects there as there is in our own asteroid belt, which we're working on the hundreds of thousands. And in fact, I don't know if you have seen this, but after Pluto, there is the possibility of getting to one of these other objects. We're hoping that, because Pluto, unfortunately, is just a flyby.
Right. Yeah. They're going to take real close-up pictures of it, but it's not stopping there. They've got other stops.
No, then it's going to take off.
Right.
But before it runs out of fuel, we're really hoping that it will actually, astronomers will actually be able to find something in its direction, in its outward direction, so that we would have a second example of one of these outer regions.
Another dwarf planet, possibly, or something like that?
Or another rock.
Oh,
or another something. Yeah. We don't, dwarf planets have to be fairly large, and they have to be at least a few hundred miles across. So we don't really, and we've, again, right now we've listed 5 of them, but we don't really know if there are
But the
any
Kuiper Belt
others.
is loaded with objects, isn't it?
Yes.
Okay. So it's just rocks and other things,
Right, some of which will be potential comets that will start coming toward our way.
Now, the Kuiper Belt is sort of considered the edge of our solar system, unless you want to count the Oort cloud itself, which is way out, halfway to the next star.
It's
right?
kind of at the, well, with a couple exceptions, right, it's kind of the edge of our, if you will, material
solar
system. However, you still have the sun's, quote, atmosphere, the heliosphere, which extends beyond that. But the solar system does go way beyond that, too, as you mentioned, the Oort cloud, which is, again, another place where comets originate.
For people to understand the vastness of just the distance of just our solar system alone, it took New Horizons, the spacecraft that'll arrive at Pluto in July, 10 plus years to get out there?
Just about 9+ years to get there. But then we don't know how long it will take before it goes someplace else.
Right.
And you figure, remember the 2 major spacecraft before that, the
Voyager
Voyagers.
are still going.
They are still going, yes, and they're traveling like around 50,000 miles per hour.
And they have left the solar system.
They have left, if you will, the sun's atmosphere.
Its influence, right?
Yes, But the sun's influence is still there because they're still nowhere near the Kuiper Belt.
Oh, okay.
So technically, we keep saying that they've hit the end of the solar system, but they haven't. Because you figure the solar system ends at the sun's influence,
Right.
which will be the Oort cloud, which
But that goes like halfway to the next star, right?
they
or something?
feel that if you use the standard candle of an astronomical unit, which is the distance between us and the sun, just about 93 million miles, that Oort cloud is considered to be somewhere between about 10 to 50,000 astronomical units.
And again, it goes to show you the vastness of space and the distances. The nearest star, the next star to our sun, is so far away with current technology, hundreds of thousands of years to get to the star? Or
Yes.
100,000 years, something like that?
Right.
I don't want to wait that long.
I know, huh? Our lifetime will not see
No.
Another star, unless one happens to just come by.
And that next closest star is actually, it's a binary or a trinary
It's
system?
It's in a trinary system,
So
yes.
it's 3 stars rotating or orbiting each other.
Right, unfortunately, it has to be one that we can't see from here. All the good stuff happens in the
Yeah.
southern hemisphere.
Yeah.
Yeah, this is the brightest star in the constellation Centaurus, the Alpha Centauri system. And the closest star is a little tiny red star, that third little minor star called Proxima. That's the one that's the closest to us. And yes, you're talking going at the speed of light, it would take 4¼ years to get there.
Now, which one of those is the most potential for planets that would be interesting to us?
Probably nothing around us,
No.
unfortunately. But we have been very lucky in the fact that the Kepler spacecraft,
That's spotting things like crazy.
unbelievable. Yes, it worked for much longer than it was believed. Unfortunately, now its job has had to shift because of some of the maintenance requirements that we can't use anymore. But just that has gotten potentially several thousand planets going around.
Fran Jackson, astronomer extraordinaire, is my guest today. It's Kepler which is just found phenomenal amounts of planets. Initially, hot Jupiters, because those are the biggest planets, and that's what they were spotting, right?
Yes, but they've actually gotten down to objects very similar in size to our Earth.
Yeah, maybe twice the size of our Earth, or maybe an Earth and a half, or something like that.
Yes, and they're still looking, they're still pouring. It'll take years before they finish going through all of the information that Kepler got from its several-year trip.
And some of those planets that are close to Earth, they're thinking that possibly they're in that star's Goldilocks zone. So,
Yes.
I mean, this is a lot of wishful thinking because it's pretty tough to make these determinations. But yeah, listen, that's the whole goal. But is it the James Webb? Is that next?
James Webb is next. That will be, if you will, the new Hubble. But that will be working not in the visible light, but in the infrared, or in
yeah.
other parts.
But
Yeah.
is that still? Will they be able to find amazing image? Will they be able to grab amazing images? Obviously.
Oh, definitely, because that will be further away. That'll be about 1 million miles away from us. So it will be
up deeper in orbit, way out.
Yeah.
Okay.
So
How much more powerful is that than Hubble was?
mainly power-wise, it's kind of difficult because the whole structure is slightly
Okay.
different. But the images, when taken, as infrared, should be just miraculous, if you will, just as we thought the Hubble was when it was first fixed.
Talk about the Hubble, because it probably the one piece of scientific instrumentation that really just changed our understanding of the universe, right?
And it got a lot of people interested because, let's face it, beautiful pictures came out of there. And the information that it got was phenomenal compared to what at that time we could do here on Earth. Now some of the telescopes that are being built are so high that they're getting images comparable to the Hubble, sometimes eventually probably even better because they can make larger diameter.
Even with the atmosphere interfering?
Many of those are, for instance, in the hills of Chile or the mountains of Mauna Kea, so they're above the major portions of our atmosphere.
Wow.
Which is why some are saying, well, maybe the Hubble might be superfluous, if you will, but I don't think so.
But it should be. I hate the fact that it's going to burn up in the atmosphere. It should be in a museum, if possible. I know they won't do that, bring it down that way. But
well, the problem is they can't.
yeah,
with
no
the,
shuttle, right?
Absolutely,
Yeah.
yes, because the shuttle brought it up. The shuttle caused it to have 5 major repair missions. Now it's just going to be there till it's done.
And there was some nerves early on, I guess, even with Hubble, because a mirror was out of alignment or something like that, and they had to go do repairs, adjust it, right?
Yes. The difference, in fact, I was speaking to someone, I just came back from a conference on this, and they were talking about the fact that the variation in the curvature of Hubble was about a 50th of a human hair.
And that made the difference.
Yes, absolutely. If you remember the difference between the original images and after the repair
The blurry
mission.
versus the beautiful, sharp.
Yes. They were able to at least adjust fairly well, by computer here, but once the repair mission happened, then the results were phenomenal.
Now, Kepler ran into problems too, right? But these couldn't be repaired?
Right, only because it's too far away.
Oh, geez,
Yes.
and they'll never be able to repair the James Webb if that goes wrong,
Right, that's why it's taken so long to get to leave the ground. I mean, it won't be till 2018 before it finally launches, if that early.
There's still one of the original rovers is still going around Mars. And I'm not talking about Curiosity. I'm talking about one of the Pathfinder, or what was the other one?
Oh, we had Spirit and
Spirit.
Opportunity.
Opportunity, yeah.
Yes, and I can never get the two
I know.
together.
Yeah. One of them doesn't work anymore, but one still does.
Right, and I believe it's Spirit that doesn't work only because it got caught in a dust storm.
Yeah, and it's
solar
panels.
panels,
Yeah.
yes.
So if a breeze came along, could it technically be recharged?
I'd like to hope so.
Oh,
Yes.
Wow, look at that.
It would take a while, but but Opportunity. I mean, this has been 11 years now. It was supposed to work for about 90 days,
Yeah.
and it's still workable. But of course, the Curiosity.
Yeah, I think the smart thing they did, the best thing they did with that was to just make it bigger, so it wouldn't get caught in these sand traps or whatever it is.
And nuclear powered.
That too.
That is not solar powered.
Oh, okay, so they don't have to worry about the sun.
Right,
Yeah.
just have to wait for the generator to die.
Yeah.
And that was supposed to last 2 of our years, which is about the equivalent to a Martian year. But it's still working.
How is it that Voyagers they're still going? What is powering them?
Basically, they also, anything that goes to the outer part of the solar system has to have some kind of nuclear generator
Okay.
to it. And because, being so far from the sun, you would
Yeah.
totally, very quickly lose the ability to actually have enough sunlight to use it.
Now, you mentioned Dawn orbiting an asteroid, and that's very impressive. What about was it the European craft that landed on a comet? That's pretty.
Philae,
Yeah, that's
yes.
pretty impressive too, right?
Yes, and unfortunately, I guess it kind of landed. It landed
Awkwardly.
yes. So we did get some images from it. Now, the main ship, the Rosetta, is sending images back because the Rosetta actually is on a similar course to the comet itself. So that's actually sending us images. Philae, unfortunately, isn't real. Well, that also had solar panels, which unfortunately, the way it landed kind of got caught in the shade.
Yeah.
So there.
A comet is so oddly shaped. It's not a perfectly round ball by any stretch of the imagination. It's like clumps of rock and ice all just kind of
Absolutely.
jammed together, right?
Yes. So unfortunately, where it landed, it wasn't really in a good position to.
And they struggled with deciding where they wanted to land that. There were like 3 different options or something, right?
And then what happened also is I believe one of its legs didn't open up properly. So that also kind of kept it from being a little bit more toward the sun, kind of kept it a little floppy, if you will.
And, as we are a capitalist society and world, and I guess it makes sense that if you're going to continue to go out into space, you have to fund these things in some way. And obviously, they've discovered that these asteroids that exist in our solar system are just filled with minerals and metals and things that are of great value to us. Eventually, we will mine asteroids, will we not?
Oh, we've been talking about that since even I was a little kid. Just basically lassoing it and bringing it back.
Yeah,
Not
like it'd be that simple.
little hard, I think. But now I believe they're thinking of probably in the early 2020s starting some kind of asteroid rendezvous, whether it would be just kind of sending someone out there, having them bring a chip back, or getting a smaller one and trying to bring it as close as possible to the Earth. That I don't think has actually been discussed totally. There are just too many options that could happen.
But it's feasible, and once it becomes cost effective, entrepreneurs will jump on that. I would imagine.
Yes. Plus, remember there are asteroids that are in our neighborhood.
Right.
Yes.
Those are kind of dangerous.
Yeah, you remember the one a couple of years ago in Russia?
That's right. Yeah.
Yes, and they figure that probably we have maybe about close to about a dozen of those, not as brilliant as that, but coming relatively close enough to the Earth that every year that something like this could happen. The problem is, though, unfortunately, that most of the time we don't realize that they're here until either they're here or they've passed us by.
And I guess when you do spot what they call a planet killer, by that time it's kind of too late. You would need like a decade, I don't know, to actually try to do something about it. Right?
Yes, you probably remember the movie Deep Impact, where they didn't have enough time.
Yeah,
yes.
they flew there to it too. And obviously the wrong thing to do would be to try to blow it up, because all you're doing is turning one object into many.
Absolutely.
That'll do much more
and they'll
damage.
continue in the same path it's going.
It seems like the right thing to do is to just nudge it out of its orbit a little bit so it just misses us. That seems to be like the simplest thing to do.
Right. One of the things that has always been a thought, right, is making something large enough that it will have just enough gravity to affect the object, to push it just a little bit further away from us, but it doesn't seem to be happening fast enough.
We've been talking a lot about space and things you can see in space. So there are actually local or regional observatories, planetariums, things like that, where people can go in Connecticut, Rhode Island, and all over New England. So talk about that briefly. I just want to make sure we get to that before we run out of time.
Oh, absolutely. We're very fortunate now, even though I teach in Massachusetts, as you know, I live in Rhode Island, and there are actually 4 observatories that are open every week, weather permitting, which means we haven't been open very much lately.
Right. Now, finally, yeah.
Yes. There is Frosty Drew, which is in Charlestown. Then Brown University, which is open every Tuesday, and that is actually an antique observatory. That's from 1891, and we have tried to keep it 1891 all this time. Then the amateur astronomers on Saturday evening have theirs in Situate, then CCRI Warwick, and then I have others from Connecticut that you probably want to hear from.
Let's talk about some of the Connecticut locations.
All right, we have Wesleyan University, the Van Vleck Observatory up in Middletown. They're open on Wednesdays. The Midtown Observatory and Planetarium at Western in Danbury, you need to call for public observing. Mystic Seaport, of course, has a planetarium. The University of Rhode Island also has a planetarium. There's a planetarium in Roger Williams Park in Providence, yes. And the Yale University Observatory has public open houses.
A little further away, but it was fascinating to learn that the Vatican has an observatory, right? They have an astronomer on staff.
Absolutely. Isn't that amazing?
Isn't that amazing? They're looking at the heavens, I guess.
Yes.
Right?
Looking with a camera. Their telescope is not meant for actual observing. It has a camera permanently mounted. But yes, it's kind of nice to think that after all these centuries
that the universe revolved around the Earth and
yes,
all that they're...
And now to find out that they have their own observatory.
Is there life in the universe besides Earth?
I think the odds are telling us there has to be.
Intelligent life? How about that?
Oh, it's going to, well, besides us.
Yeah. How could anybody be more intelligent than us, right?
Absolutely.
Is there, would you like to send anybody to a website to learn more about what you do or anything along those lines?
Absolutely. Probably the best way to do it would be, I am associated with the amateur astronomers, that they have their website called Skyscrapers. So it's the skyscrapersri.org.
Okay.
Or you can just send me an email at Francine_Jackson@brown.edu. Be glad to answer any questions.
Are you excited about July when we can look at Pluto finally?
Oh my gosh, yes.
Sounds good. Fran Jackson, astronomer, also a visiting lecturer of physics and earth science at Framingham State University. We learned a lot today. We could do a whole other show on this, but thanks for coming back. I appreciate it.
Thank you. I appreciate it myself.
That is our show for today. You can see this show and many others on our YouTube sites. Until next time, I'm Sean Murphy. This is For the Record. Take care.